Hello everyone. In this video, we are going to do some multiplications and also know how the computer does it. So literally, we know that 5 times 3 gives us 15, just as shown here. So the computer does its multiplication like this. What it does is it first converts the decimals into binary. So this is for 5 and this is for 3. Now, I did the 3 in a color code because I want us to be able to identify some stuff which I will explain later. So before we able to do the multiplication, there is something we call the bit position, and that is the reason why I color coded them. So we first need to know that the bit multiplier is the 3, we are going to multiply the 5, and the bit position is in a way that it starts from 0 from the right, so 0, 1, 2, and 3. So here it means that my 1 will be 0, the next one will also be 1, then this 0 will be 2, and this 0 will be 3. So basically that, like this. So this becomes the bit position. Now, to do the multiplication, we're going to use this individual bits here to multiply all of the 5 bits. So we're going to use this 1 to multiply all of this to multiply all of this, the 0 to multiply all of this, and then the green 0 to multiply all of this. So just like this, as I have demonstrated here. Good. Sorry. All right. Just as I've demonstrated here, we have 0, 1, 0, 1 times 1 equals that. So if you multiply 1 times the whole of the 5 bits here, you will get what? 0, 1, 0, 1. The same for this. If you multiply 0 by the 5, you get this. And if you multiply the 0 by this 5 bits, you're going to get 0 again. So basically, 1 times any number still gives you the same number. 0 times any number gives you 0. Now, the bit position is what we are going to concentrate on because it's going to help us in the shifting process. Okay, so I'm going to add another cell here to help us do the shift. Right, so I got this as an answer. Okay, but the position of that bit is 0, so it means I'm not going to do any shift in it. And then I got this as an answer from the multiplication, which is this guy, but the bit of the position of that bit is 1, so it means that I have to shift this bit by 1. So in doing a left shift, we all know you just have to drop the very first number, which is this guy, and then you are done with what? The bit shift. So if you're using the circular shift, it means you have to bring back the 0 behind here. Yeah, so as they move, you know that zeros fill the empty spaces. For the circular shift, whatever you drop here, it comes back. But I'm just doing a left shift, so I'm dropping whatever is there off. Now, this second result, we had what? 0, 0, which is here. So guess how many shifts I'm doing based on the position? 2. So it means that I'm doing the shift 2 times, and I have to fill the empty spaces here with what? 2 extra zeros. So I'm going to underline those ones to know that they are the ones we just added. Control U, like this. Beautiful. And this is the next or the new bit that came in, like this, for us to identify the new bits that came in. So here I'm going to shift this to how many times? 3 times. So it means these first 3 are going off, and then new bits are filling it, and the new bits are all 0, 0. So here I fill it with what? This new bit, which is what? This guy. So after doing the shift, you will notice that we have a new order of arrangements, because what actually happened here was quite unique. The ones moved up a little, and that is what is helping the shift. So we have looked at how to do the shifting. So we use the left shift, and the answers I have here is the same as this one. So there's no difference. I just color coded this for the addition process. So you notice that if I add all the values here, I get 1. If I add all the values here, I get 1. If I add all this, I get 1 here, 2, 1. So basically, after all the multiplication process and the shifting, when you add it, this is your results. Now, let's confirm if our result is correct. So I used the AI to check. Give me a second. Right. So this is the question I asked the AI. What is the deck of 1111? And it says the decimal value of the binary number 11 is 15. So as you can see, that when the computer does the binary operation using the ones, and then you convert it back, you get what? 15. Now, there are some numbers that could span from the 4 bits. Okay, so what happens in that case is that you have to allocate extra zeros to cater for those sides. So for instance, I can do 1, 2, 3, 4, increasing the bit size. So I'm now going to use 8 bits. And then here 2, 1, 2, 3, 4. Here 2, 1, 2, 3, 4. Here 1, 2, 3, 4. And the last one, 1, 2, 3, 4. Right. So if you have this, it doesn't change the value of the numbers. This is still 15. So in the case where there are numbers that we are doing the shift mode, or maybe, for instance, if we have to shift this one again, if it's just with a different number, it means this one is going to come here. You get a zero replaced. So in the addition, we don't lose this value for the numbers to automatically change. So this is how you do the shifting and the multiplication.